This lesson is called Properties of Exponents, and this box right here is probably going to confuse you a little bit, but I'll try to make it clear as we go. Okay, we've got a couple of rules here. It says to multiply powers with the same base, keep the base, and add the exponents. A lot of times rules in math books are stated like this right here: x to the a times x to the b equals x to the a plus b. So you need to learn how to interpret those things. So what our rule says is if we have some number and it's the base in both of these cases, so and each one of these is raised to a power, when you multiply them together, the answer is going to be that same base with the a and the b added together. Now that sounds confusing right now probably, so let's give an example. Okay, so let's plug in 4 instead of x, 5 instead of a, and 2 instead of b. So they're saying 4 to the 5th times 4 to the 2nd equals 4 to the 5 plus 2, or 4 to the 7th power. What that does for you is, if you have been given a problem that says 4 to the 5th times 4 to the 2nd, you know the answer is 4 to the 7th. You kept your base and you added your exponent. So it's actually quite simple once you have a little understanding of the rule. Now here's why that works. If you've got 4 to the 5th times 4 to the 2nd, well, 4 to the 5th is this, and you're timesing it by 4 to the 2nd, which is this. Well, don't you have 4 to the 1, 2, 3, 4, 5, 6, 7th power? Okay, so instead of writing all that out, you can just use the little algorithm, which is keep the base and add the exponents. Now there's a similar rule for division right here. To divide powers with the same base, keep the base and subtract the exponents. And here we have this little rule: x to the a divided by x to the b equals x to the a minus b. And again, we'll plug in 4, 5, and 2. And so 4 to the 5th divided by 4 to the 2nd is 4 to the 5 minus 2, or 4 to the 3rd power. If I were to write that problem out in expanded form, it would look like this: 4 times 4 times 4 times 4 times 4, that's 4 to the 5th, divided by 4 to the 2nd power. And then what would happen is these 4's would cancel out top and bottom, and it would leave you with just these 3 4's. So the answer would be 4 to the 3rd power, which is what we said. But instead of doing all of this, you can just follow the algorithm again. Okay, just one more little interesting thing here. Any non-zero number raised to the 0 power equals 1. Okay, so as long as x is not 0, if you raise it to the 0 power, it equals 1. And I know that that sounds kind of crazy to you probably, but when you raise something to the 0 power, it equals 1, and that's something you're just going to have to memorize. Okay, if you understand the rule, then the problem should really be pretty simple. So notice that we've got the same base and we've got multiplication. So the rule tells us to keep the base, which is 10, and to add the exponents. 6 and 9 are 15. So 10 to the 6th times 10 to the 9th equals 10 to the 15th. Don't be thrown off by the fact that they gave you a base of a. It doesn't really matter that it's a, because you're just going to keep it. So we've got the same base and we've got multiplication. So we're going to keep the base and add the exponents. 8 plus 6, 14. So a to the 8th times a to the 6th is a to the 14th. Down here, same base and multiplication. So keep the base, add these exponents, negative w to the 20th power. Same base, multiplication. Keep the base, add these exponents. negative 12 to the 31st power. Okay, now we've got division problems, and it says to write the quotient as 1 power. So we've got the same base, and we've got division, so we keep our base and subtract our exponents. So we've got a to the 7th power. Same base, division, keep the base, and subtract the exponents. Negative 13 to the 5th power. Same situation here, keep the base, subtract the exponents, 19 to the 11th, and here we've got 21 to the 2nd power, and we're not going to evaluate that because it says to write the quotient as 1 power. In those multiplication problems we did a minute ago, it said to write the product as 1 power. This next section says to write the product or quotient as 1 power. It's really the same thing we just did, only they're mixing the multiplication problems in with the division problems, but hopefully you can easily tell the difference. This one's going to be r to the 17th because it's multiplication. We add these exponents. This one's division, 16 to the 10th power. Keep our base here, negative 17, it's multiplication, so we're going to add the exponents to the 15th power. Again, we have multiplication, 27 to the 13th power. This one, number 23, don't be bothered by the variable for the base, just keep it. Add your exponents to the 35th power. This one's division. Keep our base, 26, do the subtraction, and we've got the 12th power. Okay, and finally we've got a couple of crazy word problems here. Hampton has a baseball card collection of 5 to the 6th cards. He organizes the cards into boxes that hold 5 to the 4th each. How many boxes will Hampton need to hold the cards? Write the answer as 1 power. So his total number of cards is 5 to the 6th, and he's going to put them in boxes that hold 5 to the 4th. So we're going to divide that by 5 to the 4th. The way we've been looking at a problem like that is like this, 5 to the 6th over 5 to the 4th. That's division where the bases are the same, so we keep the base and subtract the exponents. So it's going to be 5 squared, and we don't need to evaluate that and make it 25 because it says to write the answer as 1 power. Okay, then this one, number 27, write the expression for a number, that's x, used as a factor 17 times, being multiplied by a number, it's that same number, x, used as a factor 14 times. Then write the product as 1 power. Keep our base, add our exponents, x to the 31st power.